Long before Earth existed, before oceans, continents, or even the sun itself, there was only darkness, vast, cold, and silent. No planets, no light, just empty space stretching for trillions of kilometers. But hidden within that darkness was the raw material for everything we know today, including you. Our story begins more than 4.6 billion years ago, inside a giant molecular cloud. These clouds are enormous regions of space filled with gas and dust, mostly hydrogen, with traces of heavier elements forged inside earlier generations of stars. They are so large that entire solar systems can form inside them, yet so cold and diffuse that they remain invisible to the naked eye. For millions of years, nothing seemed to happen. Then, somewhere nearby, a massive star reached the end of its life. When a giant star dies, it doesn't fade quietly, it explodes. A supernova tears the star apart in an instant, releasing more energy than the sun will produce in its entire lifetime. That explosion sends powerful shockwaves racing through space. When one of those shockwaves slammed into our quiet molecular cloud, it changed everything. The shockwave compressed the cloud, squeezing its gas and dust closer together. Gravity took over. Regions within the cloud began collapsing inward, pulling more and more material toward their centers. What had once been a calm, drifting cloud transformed into a chaotic region of collapse and motion. This was the moment our solar system was set in motion. As gravity continued its work, one region of the cloud grew denser than the rest. Material fell inward faster and faster, heating up as it compressed. At the center, pressure and temperature rose to extreme levels. Eventually, this growing mass ignited nuclear fusion. Hydrogen atoms fused into helium, releasing vast amounts of energy. The sun was born. But the sun did not form alone. Around it, leftover gas and dust flattened into a spinning disk. This structure, known as a protoplanetary disk, was the birthplace of every planet, moon, asteroid, and comet in the solar system. The disk existed because of angular momentum. As the cloud collapsed, it spun faster, flattening into a disk much like a spinning ice skater pulling in their arms. Inside this disk, conditions were anything but uniform. Near the center, temperatures were incredibly high. Only materials with very high melting points, metals and rocky minerals, could exist in solid form. Farther out, where it was colder, ices could survive: water ice, methane ice, ammonia ice. This temperature gradient would decide the fate of every planet long before they fully formed. At first, the disk contained nothing larger than microscopic dust grains. These particles collided gently, sticking together through electrostatic forces. Over time, dust grains became clumps. Clumps became pebbles, pebbles became boulders, and eventually gravity began to play a role. Once objects reached a certain size, their gravity helped them grow faster. They pulled in nearby material, sweeping up more dust and rock as they orbited the sun. These growing bodies are called planetesimals, the building blocks of planets. Some were only a few kilometers across, others hundreds. Collisions were constant. Some were gentle mergers, others were violent, shattering objects into fragments that later reassembled. This was not a neat process. It was chaotic, messy, and brutal. But over millions of years, order slowly emerged from the chaos. Closer to the sun, where temperatures were too high for ices to exist, planetesimals were made mostly of rock and metal. These rocky bodies collided and merged, growing larger and larger. Eventually, they formed the terrestrial planets: Mercury, Venus, Earth, and Mars. Farther from the sun, beyond a boundary known as the frost line, ice could survive. Planetesimals there contained not just rock but large amounts of frozen water and gases. These icy cores grew massive enough to pull in surrounding hydrogen and helium, becoming the gas giants and ice giants. This is why the inner solar system is dominated by small, rocky worlds, while the outer regions are home to enormous planets surrounded by thick atmospheres and moons. It was not chance, it was physics, temperature, and timing. Meanwhile, the sun continued to evolve. As it ignited, intense solar winds blasted outward, stripping away leftover gas from the disk. This effectively shut down planet formation, freezing the architecture of the solar system into place. What remained were planets on stable orbits, along with asteroids and comets, remnants of a process that never fully finished. By the time the dust settled, the solar system had taken on a recognizable form. The sun burned steadily at the center, planets circled in relatively flat, orderly paths, but this was still a dangerous place. Young planets were hot, unstable, and constantly bombarded by debris left over from formation. Earth had not yet become Earth as we know it, but the stage was finally set. Everything that would later shape our planet, its size, its composition, its distance from the sun, was determined during this early era. Long before oceans formed, before life appeared, before the moon existed, the fate of Earth was being written in a swirling disk of gas and dust. The solar system was born not in peace but in collapse and fire, and from the death of an ancient star came the conditions that would eventually allow a small rocky world to host life. In the next chapter of this story, we follow one of those rocky bodies as it grows larger, hotter, and more violent on its way to becoming the planet we call home. Please subscribe to this channel to support us to create more videos.